Last but not least, we are going to look at renewable energy. So there are a lot of renewable energies, and we will start with biomass, but we're going to try and go through them all. And so again, here are your essential knowledge points. Make sure you know them. So biomass is really anything that originally comes from the sun, right, through photosynthesis. So it could be wood, charcoal, manure, right? The manure is coming from the sun by way of consumers that eat producers, right? Plant remains, which we call green manure, municipal solid waste, so really just garbage. Ultimately, organics and such like that. Obviously, there's non-biological material, municipal solid waste, but we burn that anyway also. And then liquid biofuels. So here we go. We get our energy from biomass in two different ways. We can either burn it or convert it chemically. And so either way, we're getting energy from all of those materials that I had just listed. And this is considered renewable because there's always going to be a source of these kinds of energies. However, they may be unsustainable, which we'll go into a little bit later. But it's thought to be better for the environment because we're using new or modern carbon to generate energy. So it is carbon that was taken out of the atmosphere through photosynthesis and put into biological material, whether it be from, directly through photosynthesis or then consumed and assimilated through consumption, right? That's modern carbon. It was in the atmosphere and now it's not in the atmosphere, but it happened relatively, recently, as opposed to fossil fuel carbon, which is considered old carbon because it takes so long to get it there. And so it's considered a little better for the environment because we're not really adding to the carbon cycle. We're not reducing our carbon sinks. It's just kind of quick carbon or modern carbon. When we are looking at solid biomass, this is a direct combustion. So we are actually burning it to generate heat, which depending on what we want to do with it, we can go further with that. So maybe we just need it for heat, cooking, heat, like heating your home, whatever it may be. However, we can also use it to, combust something to generate steam by heating water to turn a turbine to then generate electricity. Wood, charcoal, manure, plant remains, not really so much. That's usually just for heat. But anyway, right, all of these things are very low cost and really available, which is great. However, you actually have quite a bit of air pollution, especially if they're indoor, like if you're using it for cooking indoors. It can be very detrimental to health. And so your air pollution includes particulate matter, which when we get into air pollution in our next unit, you'll see that these actually are quite detrimental to health and also really just to the environment. But particulate matter, VOCs, which are volatile organic compounds, they're compounds that evaporate very quickly and can be very detrimental as well. Carbon monoxide, carbon dioxide, so that X denotes a number, whether it be a 1, a 2, a 3, whatever it is. So carbon oxides, carbon monoxide, carbon dioxides, nitrogen oxides, nitrogen monoxide, nitrogen dioxide. And then not to mention, if we're using wood for combustion, it can, if we're not cutting that wood down sustainably, it can cause deforestation, which, we've talked about in clear cutting. Not good. The other solid biomass is trash to energy, or municipal solid waste. There is a plant up in New Haven where here in Stamford, our trash used to go, no longer. We don't ship our municipal solid waste up there anymore. Now we go to a landfill. However, we used to ship it to this, so, relevant. Anyway, basically the garbage gets dumped, it gets sorted. There are certain things that go in the garbage that you definitely don't want to burn. For example, or actually it's more that you don't want to burn them. You don't want to then chop them up into tiny little pieces. For example, if you have like a gas tank, like what you would use on a barbecue, like a grill, and you take a propane tank and it goes through the whole system and ends up getting chopped up into tiny pieces to get burned, that can explode. And actually there have been times where the roof has blown right off the building of a trash energy plant. So that trash actually needs to get sorted. There are a lot of recyclable material that gets thrown away. It shouldn't be chopped up and burned, but it does get burned, right? So, good, bad, however you might think of it, it's a way to get rid of our trash for sure. The worst smell I've ever smelled in my entire life was when I went to a trash to energy plant tour, and it was the Monday after 4th of July weekend, and that trash had been sitting there for quite some time. So usually they process it day of when it comes in, but it had been sitting for a while, and it was the biggest amount of trash I've ever seen in my life, and it smelled so bad, so bad. It would burned the back of my throat bad, which means there are volatile organic compounds in there just decomposing. So if you could imagine. Anyway, I digress as per usual, but right, it gets chopped up into tiny little pieces. We burn that trash, which heats the water, generates steam, turns the turbine, and gives us electricity. But of course, you have those emissions that need to be treated because there are things that get burned that have pretty noxious fumes, not to mention, right, your sulfur oxides, your carbon oxides, your nitrogen oxides. All of those need to either get treated or just emitted, however, whatever the regulations may be. And then there's the ash that's left over, and that ash could also contain heavy metals and stuff like that. But anyway, that ends up getting shipped. Sorry, I got an email. Getting shipped over to a landfill. So obviously, volume-wise is much less, but ultimately your trash still does end up in a landfill, even if we get energy out of it. So beyond solid fuels, we have liquid fuels. One liquid fuel being ethanol. Ethanol is mixed in with your gasoline with lower quality engines. You have a knocking that ends up happening in your engine. It's kind of inefficient, and so it actually ends up reducing how hard your engine's working and reducing that actual physical knocking that you can actually audibly hear in your engine. The higher quality engines don't need as much ethanol to kind of reduce that knocking, and so that's where you get your qualities of gasoline. So if you think of your 93 Super as opposed to your 87, where, it has more ethanol in it. So, it does make your car a little less efficient because you're not getting as much energy from that ethanol as you would from pure gasoline, pure oil, crude oil, gasoline. But it does have a reason to be in there beyond fuel efficiency. The higher up you go in ethanol, the less efficient it's going to be in terms of gas, compared to gasoline. And there are engines that do run on pure ethanol, or not pure ethanol, but high ethanol. An E85 engine is what they call it. And you have a very low energy return, right? So in order to make it, you're not really going to get that much energy out of it. But anyway, so, it does obviously emit way less carbon dioxide and carbon monoxide and other particulate emissions into the air. So environmentally awesome. But is it? Because we use crops to make ethanol. And while sugarcane is actually a perennial, which is better agriculturally, corn is an annual, and so a lot of ethanol is made from corn. And so not only are we using the land, we're using unsustainable agricultural practices such as monocropping, pesticides, all of that good stuff, or bad stuff, I should say. And so, ethanol is kind of this it doesn't pollute as much, but it's also not really super good for the environment, but it's renewable. I don't know. Okay, so here's your biodiesel, is also a liquid biomass, and so it's made from modified vegetable oil, so you can use used vegetable oil. Mostly we use soybean oil, so the oil that restaurants use for French fries and to fry your fish and chips. Well, chips are French fries, so, I'm redundant there. You get it. But anyway, basically you take that oil and you do a chemical conversion to get what you need to run a diesel engine. Most engines can actually run on regular diesel, so petroleum-based diesel and biodiesel mix, like an 80-20 mix. Most engines can handle that, but if you're going to run something on 100% biodiesel, the engine needs to be slightly modified. There are companies out there that are converting vegetable oil in large quantities, but they're kind of few and far between, mostly in rural areas. And either they're converting the vegetable oil or they're producing it through algae. And the algae actually produce biodiesel all on their own, which is pretty cool. And also, they are taking in carbon dioxide through photosynthesis. So, double whammy. But, the scale at which it needs to be done, are we actually able to fully replace diesel and, crude diesel as crude oil-based diesel? Meh. Maybe we could use it as a transition as opposed to a full replacement. So moving on to a different renewable energy, solar energy. Again, please make sure that you know your essential knowledge points. So when everyone thinks of solar, I'm sure they think of solar panels, or the more scientific term are photovoltaic cells. And so the way a photovoltaic cell works is it captures that light energy that you get from the sun. So it's actually the photons, the light energy, and it converts it to electricity because the light actually allows some of the electrons in the semiconductor to loosen and flow. And so really what electricity is a flow of electrons. So it makes use of that loosening of electrons to and the flow of electrons caused by the photons hitting the semiconductor to generate electricity. You can see really, really small scale, side of the road, your solar lights in your yard, whatever it may be on the small scale, they actually have a small battery that can store it, but it's very, very small. And so, the cost is low and it's very short term. So it can kind of take you overnight, but, needs to be recharged every single day when it's sunny out. And then for your home, as we see, Connecticut is actually trying to solarize. Actually, there's a company called Solarize CT. There's a lot of incentives out there, and so Connecticut's actually doing a really good job on trying to get homes that would benefit from solar panels to actually get them installed. They used to be a lot higher cost. Now they're better with incentives and financing and all of that good stuff. Most homes are connected to the grid because a battery large enough for home is actually really expensive, and the technology is like, it's expensive. And so it's coming there. It's coming there. That's weird. We're getting there. And I think I'm going to have to change this PowerPoint in the near future, because I think that we will get there, that we will be able to have these storage batteries in our homes so that we won't have to be connected to the grid. But we're connected because we don't have the storage capacity to keep us powered in our homes overnight and on cloudy days and in the winter when the sun isn't out for as long. And so, when you're not generating power, you're using electricity from the power company or the electric company. And when you are generating power, usually the electric company will give you credits for excess power that you are not using. So that's how most homes are set up. What I didn't mention on this slide, and I skipped that bullet point, I apologize, is that photovoltaic cells, while you're using them, are zero emissions. There's no carbon dioxide or anything like that coming out of them. And so it's very clean. However, getting there and recycling, or, the waste after those panels have expired, they are, high cost environmentally, not only environmentally, also monetarily, right? But environmentally, to create the panels, you have to mine the material, you have to construct the solar panels. And so while they're zero emissions, while you're using them, getting there environmentally can be an issue. So on a larger scale, where you look at these solar farms, you have massive amounts of solar panels, and they call this utility scale electricity. So this would be your, these power companies that are generating power, that are supplying you. Many of these have storage that are on site so that they can power you not as intermittently with the day and nighttime. Problem is, they take up a lot of space. Usually you find them in the desert because there's no shade and there's a lot of space out there. And so, who cares? It's the desert, right? But it is an ecosystem. And so we are changing the landscape there, right? Some habitat destruction. We're also changing local climate. The shade that is generated underneath there is actually growing vegetation. And that vegetation actually, causes a change in the climate through evapotranspiration and whatnot. So, it's a change that's not natural, but, we're human and we can't not change the earth at all. So, there's a lot of cost benefit that we have to think about. There are some farmers actually able to farm under these, which is pretty cool. So, I don't know. So, another kind of solar power is active solar. And it's concentrated solar power, and you can do that through a few different ways. But basically, it's using lenses and mirrors to concentrate that heat. So it's using the heat, not the light, but the heat from the sun, to heat up steam to turn a turbine. Well, usually. So in central receiver and distributed receiver systems, it's heating up steam to turn a turbine. So the central receiver is basically going to a central tower. The tower is collecting all of that heat that generates the steam to turn the turbine, right, heating the water. The distributed receiver is actually either like oil or water that's coming through. You can see in that middle picture there, distributed receiver. And so the water is carrying the heat to turn the turbine. The water is heating up to heat the more water to generate steam to turn a turbine. Whereas in these parabolics, these circular ones, you see the engine right there is actually called the Stirling engine. And so what that's doing is that it's actually generating the electricity right there. And so there are gases inside this engine that when heated are expanding, which turn the turbine. So generating electricity right on the one solar panel, parabolic solar panel. So that's pretty cool. Lots of different ways. All right. Whereas passive solar is really just using design and orientation. So basically, it's reducing your need for electricity by offsetting what you would need for like heating and cooling through design. So the design itself is actually reducing your need for that electricity. And so it depends on where your windows are. Usually the windows would face south to make use of that solar angle coming down. We've talked about that solar angle before, right? So in the winter, it's more, it's not as a direct hit to the earth as in the summer where it's more direct. And so you can see in the picture, in the winter, it's making use of those solar rays coming through the window, whereas in the summer, you're making use of awnings to actually block the sun coming into the window. So you're reducing the need for heating and cooling. You also, right, the quality of your windows, single pane isn't as insulated as maybe a triple pane with argon in the middle, like super, super fancy, very expensive windows. And then, of course, you can use shades, right, window shades. Also, we make use of a thermal mass. So you have usually masonry in the back of the house, so that north side of the house, to kind of absorb the heat. So concrete, brick, stone will actually absorb the heat in the winter when that sun comes through the window, whereas in the summer it's actually cool because it's not getting hit by the sun, and so it's cooling and radiating into the house. Also, obviously, insulation is very important to reduce your heating and cooling costs. And so another thing that's in here that I don't have on my PowerPoint but is in the picture, you can also use passive solar in heating up your water. So you can do a solar water heater and then store that water in a water storage tank like you would in any house, but instead of it getting heated by whether it's oil or natural gas, you're actually, or right, electricity, you're actually heating the water through the sun and then storing that heated water in a storage tank. Pretty cool. And another way we can use passive solar is through solar ovens. Solar ovens are just concentrating that heat, just like you did in the concentrated solar power. But instead of using it to generate electricity, you're generating it to use heat. So in France, you can see this massive building, super, super hot temperatures. Really, it's just in the design. And so mirrors, but it doesn't have to be mirrors also. It can be, just in shape and concentrating all of that heat in one place. They're also very useful in developing countries. So to reduce air pollution, using wood inside, you can use solar ovens because they obviously have less emissions and are much healthier for people. And so you can boil water to reduce waterborne illness. You can cook in it. I've made a chicken in a solar cooker, but you got to get the sun just right. Like you can't do that here in the Northeast in the winter because the sun is not direct enough. It really needs to be like in the summertime when the rays are very, very direct, and also, sometime in the middle of the day. So, positives and negatives, just like anything else. So hydroelectric power is yet another energy source that we can generate electricity from. When we think about hydroelectric power, I think people tend to think about the classic dam with the reservoir behind it. And that is true. That is one kind of hydroelectric power we'll go over, but there are other kinds too. Let's find out. So as we had said, right, this is the classic dam, or what we call an impoundment. So what happens is water is stored behind the dam in a reservoir. So a river is dammed. We build a blockage along the river. And so the water is really just building up behind that construction, behind that dam. And so it is stored in the reservoir. So if you imagine behind the dam, it's actually flooding to make the reservoir. And so what used to be river is now a big old, what looks like a lake, right? So there's environmental impact there, of course. And so the water is stored and then directed in pipes down to the powerhouse where there is a turbine. And then that kinetic energy of the falling water spins the turbine, which then generates electricity. And so the further the water falls, the greater amounts of electricity we're going to generate. And so just like anything else, as I keep saying, there are advantages and disadvantages. You have a high net energy. You can get a lot of energy from a dam. It's really efficient. It can help with flood control downriver. And then, of course, there's also recreational uses of the reservoir behind it. So fishing, boating, swimming, depending. I mean, you know, we also use these for drinking water in the reservoir. So, you know, it might be regulated in that way if we are using it as drinking water. So not all reservoirs are used in that way, but some, most, I don't know. Anyway, also, right, there are also disadvantages. So you have high construction costs in money and also in emissions, right? It takes a lot of carbon dioxide emissions to actually construct the dam. And then, of course, the environmental impacts is a huge disadvantage because, you know, actually, this is super controversial in the environmental world. Most environmentalists are not pro-dam, those dams, because you flood an area, like I said before, the area behind the dam was not flooded before, and now it becomes a big old lake. And so you lose a lot of ecosystem, or you're changing the ecosystem in that way. You have a lot of, animals need to move or they get drowned. So, you know, there's that. Also, the sediment that flows down the river actually gets caught behind the dam. And so what ends up happening is that the sediment settles behind the dam and it starts to decompose. And so you end up with actually some methane emissions from behind the dam. But not only that, the sediment that's not getting down the river is not carrying its nutrients with it. So sediments are nutrient heavy. And so what ends up happening is that downriver, you actually have quite a bit of nutrient depletion. And then you also have an interruption of migration up the river. So for example, you have fish migration like salmon who have to swim upriver in order to spawn in their natal streams. So like where they were born, they go back to. But one of the ways that they get around this is what you can see here is actually called a fish ladder. So the fish, instead of swimming upstream, are diverted into this construction area where they're able to kind of go up the ladder into the reservoir. So this is a solution to the interruption of fish migration. So other ways that we can generate electricity from hydroelectric, so from water, is run of river. So what run of river actually does, it diverts the river, part of the river, through a channel. And so that channel has the turbine in it. And so it flows through the turbine down back into the river. And so, you know, it's reducing the environmental impact because you don't have that flooding impact that you had with the reservoir with a dam. It really can only be done on a small scale because the amount of water that's running through the turbine is actually not very big. Also, there's no storage, right? So you don't have that reservoir above, and you don't have control about how much water is actually coming through. And so you don't really have a way of saving electricity for when you want it or need it. And, you're also dependent on rain events and what the flow of the river is looking like at that time. Another type of hydroelectric is tidal energy. So using actually tidal flow to turn turbines. So it is very site specific because you need pretty high highs and pretty low tide levels with a very fast flow of the tide coming in and out. There are places around the world that definitely happens. It's always on a coast, right? Because you do need that tidal energy. But it does spin that turbine with the flow of the water. Next up, we have geothermal energy, also very site specific. And so geothermal power is only really possible where the Earth's crust is very thin and heats water close to the surface, at least in terms of creating electricity. So there is geothermal energy that you can use where we're not creating electricity. We're actually helping with energy efficiency and heating and cooling issues. So using the earth to help with your heating and cooling. But here we're actually just talking about electricity. So let's do that. So electricity is really only possible with geothermal energy, really in places where there is tectonic or seismic activity. So you need the Earth's crust to be thin so that way the magma can actually heat that water and get enough heat so that it generates steam. Water is, like I said, heated by the magma close to the surface, and so you have steam where it can drive the turbine immediately. They have steam where it's a little more wet, so more water droplets, like liquid water as opposed to gaseous water, and it's set to a separator to extract it. And then, just like in your house with heating and cooling, you can use hot water in heating and cooling. Oh, I already said that. Well, you know what I mean. Okay. Here's an example of a geothermal power station. Pause it. Take a look. Okay. So, again, advantages and disadvantages. It's super, super efficient. It has very low carbon dioxide emissions. It is low cost if the area is suitable for it. And all in all, just very low environmental impact because we're not burning anything to spin that turbine. However, right, like I said, it's only very, very site specific. It's actually pretty loud as well, and then it actually smells because it is like coming from the earth. So there's actually gaseous material that's coming from the earth too. So you have a lot of sulfur odor, which kind of smells like rotten eggs. So sometimes it gets a little stinky. It can be depleted if not managed well. And then land subsidence, which is actually like sinkholes due to extracted water. So if we extract too much water and we're taking too much water from the pore space in the soil, then the soil can collapse on itself. So, yikes. All right, we have our hydrogen fuel cell. This is a pretty exciting resource that is up and coming. Hydrogen fuel cells are exciting, but also problematic. Everyone thinks it's kind of the future, but it hasn't really taken off for a few reasons. But anyway, let's talk about how it works. Basically, it's combining oxygen and hydrogen from the atmosphere or from other sources, and it pushes it across this cell or catalyst to make electricity. And the reason why it creates electricity is because the electrons actually can't go through the catalyst, and so it ends up creating a flow of electrons, and a flow of electrons is electricity. That's what electricity is. So basically, by doing that and combining the oxygen and hydrogen, the only emission is water, which sounds awesome. But, there's issue with like where the hydrogen is coming from. It has to come from somewhere, and especially if we're going to be using it to drive or use it for more electricity than what it's used for right now, which is really just small portable emergency backup power, like on the side of the road or something like that, for like street lights. But it's the hydrogen is really formed in larger amounts using fossil fuels. And so, right, you need to put in energy in order to make the hydrogen to make this work. And so it can be expensive, and it can also have some environmental impact. So, although the hydrogen fuel cell seems awesome, it definitely needs more better technology, better technology, in order for it to really become a fuel source that I think would be good. Also, hydrogen is highly combustible, so there's also that. Ooh, boom. Oh my God. Just kidding. Okay, moving on. All right, so wind power, which is my favorite energy. I'm a big fan. Ha, 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 ha. Okay, let's take a look at the different kinds of wind. So a wind turbine is a really simple machine, right? It just uses the wind to turn the turbine, which generates electricity. It's clean and renewable when it's being used. However, manufacturing and construction is an issue in terms of emissions. So, right, unless we're using renewable energy to make them, we do have to use energy to make them. But like I said, like with everything, there's a cost-benefit analysis. And then they have a certain lifespan, and so when we decommission them, we need to figure out what to do with the waste. And, that can be difficult, whether we're recycling them or burying them in a landfill, right? But they do have a fairly long lifespan, about 25 years. But is that really renewable? I don't know. One thing that people are pretty vocal about is the noise, which actually the noise of a wind turbine is not so bad. It's actually lower than a lawnmower. So it's not hugely loud right underneath it. And birds and bats can collide with it. And so, that's also highly debated if that's actually happening as much as people are saying. So, although, wind turbines might be killing birds and bats, there's also cats are also killing birds and bats. So as you can see by my graph on the side, offshore wind power is a little bit different, where the vibration from the wind turbine can actually have some hindrance on echolocation. So, there is some environmental impact, but overall the footprint is fairly low, it's pretty good power. However, it is site specific also. It needs to be fairly windy in order to generate a good amount of electricity. So like I said, right, land and offshore are different. You have transmission infrastructure. So it's like easier to transmit power on land than in water. On land, there's less wear and tear of your turbines because in the saltwater, it can get things corrode easier. Like I said, there could be noise pollution, although not massively loud, as you guys see, right? At the little graph at the top, it talks about, if you're right underneath the turbine, it sounds like a lawnmower. If you're, a little bit further away, it's like a vacuum cleaner. So it's not terribly, terribly noisy. And then if you're like living in a residential area, it's pretty low, right? It's like the same as your refrigerator. So it's just like a little hum. And then, on land, wind is more intermittent as opposed to in the water, you have a lot more steady winds. And so because you have more steady winds offshore, you need less. And so you have less visual and noise impact out in the ocean. And although, like I said, that noise pollution or the vibration pollution, really, if you want to call it that, can interfere with some echolocation. We're not super schooled on how that is, so that's being studied currently. And it does create habitat for marine organisms. So in places where there's coral, right, coral can actually build on the structures of the wind turbines underwater. And also, fish tend to school around them because there's a lot more food on surfaces. And, not so great. Offshore wind is more expensive. I mean, just the whole idea of constructing something in the ocean and then bringing power lines to land it's a feat. And so with all of this electricity, right, we want to use less is really the ultimate goal of our solution here, right? We want to conserve energy. And so we is on small scale, you at home, you can adjust your thermostat if you're not using heating and cooling costs. You can help your wallet and by also helping the environment. And so if you pop your thermostat up in the summer, so to make it warmer, you're not using as much electricity to cool your house, right? Also insulating it, you're not using as much heating and cooling costs as well, using more energy efficient appliances. So older appliances or less energy efficient appliances use a lot more electricity. And then also just landscaping in that respect, also design when we talked about solar, like passive solar design, but in using landscape and house design to reduce your heating and cooling costs and your energy efficiency. On the large scale, we can improve fuel economy. So, right, cars that are better, and we have electric vehicles. Unlike the other side there, where we're not really using fuel, right? We're just using electricity. But then, of course, we have to think about where our electricity is coming from. Use public transportation. More people on a singular vehicle is going to use less energy. And then also, like I said before, in green building design, so just in architecture, there are LEED certifications. And so in LEED certification, buildings can gain points for their energy efficiency, their water efficiency, indoor air quality. Oh, bless me, I'm so sorry. Right on video, but I'm not going to start over now. So there you go. You ended with me sneezing, and you're welcome. Okay, and so thus concludes our energy PowerPoint.